Hey everybody, welcome back. Today we're going to be moving on to Chapter 4, Lesson 3. Chapter 4, Lesson 3, we're going to be discussing properties of exponents today. Okay, so I hope you're all ready to go. And you can start with these 4 warm-ups, please. So make sure you are answering them, but also understand how you came up with the problem. Okay, so pause the video, try these problems. Go! All right, so you have the very first one. It is 3 to the third. 3 to the third power. What does 3 to the third power mean? It means 3 times 3 times 3. Do not get caught up in taking 3 times 3. Don't get caught up in taking your base times your exponent. We don't want to do that, okay? Because that just leads to more habits later on. Okay, we want to take this and understand the meaning that 3 to the third means 3 times 3 times 3. Your answer, 27. Next, 4 times 4 times 4 times 4. Another way to say this, to go backwards from number 1, would be 4 to the fourth. And when I take 4 times 4 times 4 times 4, I get an answer of 256. 256. Okay, just moving right down the line, 4 times 4, then multiply that answer by 4, then multiply that answer by 4 one more time. Next one, b to the second for b is 4. I'm going to plug in this 4 here, and I get 4 to the second, which is 4 times 4, which is 16. All right? Breaking it down, understanding what that exponent means. All right. Next one, the last one, you would take n to the second r. What does that mean? What is happening between n to the second and the r? Multiplication. Okay, multiplication. So when we do this, I want you to plug in numbers first. So I want to take 3 to the second. Then I'm going to take that answer and multiply it by 2. So 3 to the second is 3 times 3, and then I'm going to take that answer, multiply it by 2. 3 times 3 is 9, times 2 is 18. 18 for that final one. Okay, so we're trying to figure out and understand how the process is going. And we're going to get into properties of exponents today. So I hope you are set to go. It will go a little quicker than the last. So get your thinking hats on. Oh, there it goes. Thinking hat on. Next. So we're going to be applying the properties of exponents. Property of exponents. So if I give you a problem like this, it says the factor of a power such as, that's 74, I apologize, 7 to the fourth, can be grouped in different ways. If you look at this, notice how I'm grouping these, all right? So we have seen these in the past as 7 times 7 times 7 times 7. That is 7 to the fourth. Okay? At the same time, if I give you parentheses and I focus my energy here, that's 7 to the third, because I have 1, 2, 3. And then I'm multiplying that 7 to the third times 7 to the first. Remember, what is the exponent on this 7 right here? It's 7 to the 1. Okay? If I look at that, I have 7 to the third times 7 to the first. How did I get 4? I took 3 plus 1. Okay, same thing at the very top, the very first example. 7 to the first, 7 to the first, 7 to the first, 7 to the first. 1 plus 1 plus 1 plus 1 is 4. Next one. All of these, again, have 7 to the first here. But on here, we have 7 to the second times, right here, 7 to the second. What happened to my exponents? 2 and 2 to get 4. I added them together. There is a definite pattern here. And here are the properties. These are must-know properties that you need to know. So write these down, okay? And if you use the algebraic side, which is the left side, okay, and you want to write those down, please do. The numerical side can give you definite numbers. So I definitely want you to write down the numerical side and the algebraic side, just so you see what is happening. So I want you to pause now, write this down. All right, so when I look at this problem, we look at these problems. We have product of powers. When I take a to the x times a to the y, I add my exponents. So just like the previous problems where I had the base of 7s, okay, and I'd add all my exponents when they're multiplying together. Notice on each one of these, this is very important, I have all of the same bases. In other words, on my numerical side, all of these are base of 6. I am able to do that because I have the same base the entire problem. For instance, I cannot numerically, if I give you 7 to the second times 6 to the third, I cannot combine these like I did this very first one. I could not combine them and make it 42 to the fifth. Or I could not combine them to make it 7 to the fifth or 6 to the fifth. It does not work there. Okay? So product of powers, when I do this problem, okay, I just scoot right over here. I add my exponents. When I'm dividing, so when you're multiplying, you're adding exponents. When you are dividing, you are subtracting exponents. The exact opposite. Exact opposite. Think about that. Product, you're multiplying. Okay, or sorry, product, you want to find in the product, you are adding. The exact opposite of product is your quotient, which means you're dividing. Exact opposite of adding is subtracting. So when I divide two numbers with the same base, I can subtract their exponents. Now, the very bottom one is a power of a power. So if I give you 6 to the fifth to the second, that means, at the very bottom here, that means 6 to the fifth times 6 to the fifth, right? I could rewrite those out, which is 6 to the 10th. Instead of writing out each individual base and their exponent a second time, you can just take these two exponents and multiply between them. All right? Be careful not to mix up the product of the powers and the power of a power. Be careful. But know these properties, because this will help you in this next assignment and on the test, and it will help you go rather quickly. All right? So, in words, if you wrote all of this down, you don't have to write this down. When you multiply powers with the same base, notice it's the same base. Same base, same base, same base, same base. Okay? You need to keep the base, and add the exponents. Keep the base, add the exponents. Okay? So remember, when you're multiplying powers with the same base, keep the base, add the exponents. Try that on these next few problems. You are going to use this answer, your answer is not going to be the numerical answer. It's going to be a base to a power. On all of our notes today, it's always a base to a power. You are not coming up with an actual number. So come up with these 4 problems and let's see them after. All right, so when I look at this, I look at 6 to the 4th times 6 to the 4th. When I do that, I take it 6 to the 4 plus 4, and you don't need to write down that middle. It's 6 to the 8th. I add those exponents because we have the same base and we're multiplying. Next one, n times n to the 5th times n to the 7th means n to the 5 plus 7 because we have the same base. Okay, different powers, which means n to the 12th. Can I combine these next two? I have 2 to the 5th times 2. Yes, I can. Why can I combine them? Same base. Now, what is the exponent on this 2? 1. 1. Yes, it is 1. So I need to take 2 to the 5th plus 1, which is 2 to the 6th. Remember, if any number to the 0 power is what? 1. Okay, so 2 cannot be to the 0 power. It has to have a power, and that power is going to be 1. Next, 24 to the 4th times 24 to the 7th. You keep your base of 24th, and then you take 4 plus 7. And you're done, which is 24 to the 11th. So make sure you know when you are multiplying here, when you are multiplying and find the products, All right? You can add those exponents as long as you have the same what? Tell somebody what you need to have in order to add exponents. Same base, same base, same base. Keep the base, add the exponents. Woohoo! Okay, now if you're dividing powers, looking at this, when you divide powers, you are subtracting. Dividing powers, again, with the same base. With the same base. Okay, you can subtract them. All right? So when we do that, when we do this, we subtract them, we get our answer. Okay? Let's try a couple. All right? So remember what you have to do and do it. So pause now, try these 3. All right? So when I do this problem, very first one, 7 to the 5th times 7, or over 7 to the 3rd. That's like taking 7 to the 5th minus 3. My answer, 7 to the 2nd. Okay? Next one. 4 to the 13th over 4 to the 6th. That is 4 to the 13 minus 6, which is 4 to the 7th. Okay? If I go back to this very first one, okay, I'm going to go back to the 7 to the 5th over 7 to the 3rd. 7 times 7 times 7 times 7 times 7. Okay, I have 5 on the bottom, I have 3. These can cancel out. I can cancel 1 7 out here, 1 7 here. 1 7, 1 7, 1 7, 1 7. Until I have 1 left on the bottom. Okay, and I'm left with 7 times 7. That's the same thing, and I could write out 4 13 times. I don't know if you want me to, okay, because of course I'd be saying 4 times 4 times, blah, blah, blah. Okay, but you are subtracting there, subtracting your exponents. Okay, last one, we have x to the 11th minus 9 is x to the 2nd. Okay, I am going to give you an extra problem here. I want to see how you do with this extra problem. I want you to find a to the 4th, I'm going to pause here, a to the 4th over a to the negative 3rd. So pause that video, try this number 5 problem. I want to see how we do with that one. Don't forget the rules of adding and subtracting integers. Go! Alright, you're done. Here we go. That means a to the 4th minus a negative 3, which is a to the 7th. Be careful on your homework. There's going to be a couple of problems like that where they try to trick you up a little bit based on negatives. So do not forget. Do not forget. Next one. To raise a power to a power, keep the base and multiply the exponents. Keep the base. Keep the base. We need to keep the base and multiply the exponents. So don't forget to keep the base, multiply the exponents. So remember what we have to do. Do not forget. Psst. Do not forget. Psst. Do not forget the rules of multiplying and dividing positive and negative numbers. So pause now. These are the last 5 that you have today. So pause, try. All right, here we go. First one, 5 to the 4th to the 2nd. Remember, that's the same thing as taking 5 to the 4th times 5 to the 4th, which is 5 to the 8th. All right, next one, 6 to the 7th to the 9th. Okay, when I take that, I get 6 to the 7th times 9 equals 6 to the 63rd. That's a big number. That is a very big number. That means 6 times 6 times 6 times 6. I'll stop there. But 63 times. Next one. 2/3. I keep this as a fraction, remember. It is 2 over 3 to the 12 times negative 3. Don't forget that you're multiplying your exponents, and I'm going to keep it as 2/3 to the negative 36. Now, remember, I cannot write this fraction as 2 over 3 to the negative 36th. I want you to see if you can tell me why. This is incorrect. What's in red is incorrect. What is in black is correct. Why can I not write 2 to the negative 36 over 3? Because I am taking 2/3 to the negative 36, not just 2 to the negative 36. If you look at the one on the left, the one in red here, I'm taking 2 to the negative 36th power. On the right, the correct answer, this starred one, I'm taking the entire thing of 2/3 to the negative 36th. All right? Next one. 3 to the third to the fourth. 3 to the third times 4 equals 3 to the 12th. Nice. The last one. 4 to the 8th to the negative second. When I multiply this out, I need to take 4 to the 8th times negative 2, which is 4 to the negative 16th. I am okay with leaving it like this, okay? So I will take I will take all of these answers just like this. Do not forget operations between integers. Also, do not forget that we also need to have the same base. Okay? That's all I have for you today. I hope you truly enjoyed it. Well, I mean, how could you not enjoy it? It's math. We gotta love math, right? So, have a wonderful day. I will see you later. Bye.